Hi, welcome to Circle Calculations 2. We'll be digging deeper into calculations of circumference, area of a circle, area of a sector, and the arc length of a sector. So let's pick up from where we stopped yesterday. Calculate the circumference and area of this circle with a diameter of 21 centimeter. So the circumference of a circle, the formula for the circumference of a circle is 2 pi r or pi d, because 2r equals d, 2 radii equals the diameter. So we can just go ahead. We'll be using 3.14 as our pi here. 3.14 times 21, our diameter is 21 centimeter, and this will give us 3.14 times 21 will give us 65.94. 65.94 centimeter as the circumference of this circle. Now, to calculate the area of a circle, the formula for the area of a circle is pi r square. Now, to find out our radius, that will be the diameter divided by 2. Remember, our pi is 3.14 approximately, or 22/7, but we'll be using 3.14 here. So 3.14, that's pi, times 21 divided by 2, that's 10.5. So this is our radius, 10.5 times 10.5. Okay, so this would give us, let's calculate that. So we have 3.14 times 10.5 times 10.5. That will give us 346.19 approximately 0.19 square centimeter. So that's the area of this circle. I hope you got that as your answer when you tried it out in the last video. So let's go deeper into some other questions, circle calculations. Remember the formula for the arc, the length of an arc, it's theta over the angle of the sector, which we use the symbol theta to denote. So the angle of the sector over 360 times 2 pi r, that's the formula to calculate the arc length. And the area of a sector, its formula is the angle of that sector over 360 times pi r square. Now let's try out some questions. Calculate the radius of a circle with a circumference of 20 centimeter and an area of 9 pi square meter. So we're not just calculating arc length or area of a sector or circle. We want to now take it deeper, make other factors in the formula the subject of the formula. So for the first question, we're given the circumference of the circle and we're asked to look for the radius. So let's try that here. Solution. Okay, so this number 1, 1i. Okay, so the circumference of a circle is equal to 2 pi r. And here we're given the circumference of this circle to be 20 centimeter. 2 times pi, we said 3.14 will be our pi. And then we're looking for r. We don't know r yet. That's the question. So all we need to do is to make r the subject of the formula. And how do we do that? We remove everything, every number, everything attached to r. Now the operations attaching 2 and 3.14 to r is multiplication. To remove these numbers, we have to carry out the opposite operation of multiplication, which is division, the inverse operation. So we divide all of this by 2 times 3.14. Okay, so that's, this will take care of this up here. And whatever we do on one side of the equation, we have to do on the other side of the equation so that the equation will be balanced. So we do the same thing here. 2 times 3.14. So this is out, this is out. we then have our r to be equal to 20 centimeter over 2 times 3.14. Okay, these two can take care of this here. That'll give us 10 here. So 10 centimeter divided by 3.14. So our radius will be 10 divided by 3.14, and that is 3.18 approximately. So radius of this circle will be 3.18 centimeters. Okay, as easy as that. So whatever value, if you are to look for the radius of a circle, if you're given the circumference or area, all you need to do is to make r the subject of the formula like we did right here. You make r the subject of the formula like we did right here. Okay. All right, let's move on to the next question. Okay. All right, so number 1.ii, we're given the area this time around. Let's start with the formula of the area of a circle. That's pi r squared. Now the area of this circle is 9 pi. So we'll put it there. The question says calculate the radius of a circle with area 9 pi square meters. So 9 pi square meters equals to pi r squared. Okay. All right, so we're going to use pi as it is. There's no need for us to change it to 22/7 or 3.14 because they're going to cut each other out soon. And then the area was also given in terms of pi, so let's just go on with that. So let's make r the subject of the formula here. What's attached to r? First of all, pi is attached to r. Let's take out pi and then we'll work on the others. To take out pi is attached to r with the multiplication operation, and like we did in the previous question, you take out anything attached to what you want to make the subject of the formula by performing the inverse operation, the opposite operation, which will be division in this case. So you divide pi r squared by pi to take out pi, and whatever you do on one side of the equation you have to do on the other side of the equation for it to remain balanced. So this would take care of this. This would also take care of this. So we are left with 9 equals r squared. But we're not looking for r squared, remember. We're looking for r. So we need to take care of the squared. To take out this square, we have to perform the opposite of operation of square, the inverse operation. The inverse operation of squaring a number or a value is finding the square root. So if we find the square root of r squared, we'll be left with r. And remember, whatever you do on one side of the equation, you have to do on the other side of the equation. So we do the same thing here. So that means the square root of r squared equals the square root of 9. Square root of r squared is equal to r. The square root of 9 equals 3. And what's our units? Meters. So the radius of a circle with an area of 9 pi square meters is 3 meters. As simple as that. Hope you got it. Okay, so let's move on to the next question. The diameter of a car is 50 centimeters. How far does the car need to travel for the tire to complete 1 revolution? How far does this car have to travel for the tire to complete 1 revolution? That's the first question in number 2. So let's try that out. The diameter of this car equals 50 centimeters. That's one information we're given. And the question says, how far does the car need to travel for the tire to complete 1 revolution? Okay, let me see if I can do a quick drawing here. So this is the center of the circle from here to here. Oh, sorry, the whole diameter actually is 50. It's 50 centimeter. And then the question is, how far does the car need to travel for the tire to complete one revolution. One revolution is a 360-degree turn. So let's say it begins to move here. It has to move from here to the point where it started to make one revolution, one complete revolution. That's a 360-degree turn. So that's like asking for the circumference of the circle, okay? Going round the tire, the circumference, the perimeter of a circle, and that's what you're going to calculate. So remember, the formula for the circumference of a circle is 2 pi r, which is the same thing as pi d. And our pi in this case is 3.14 times, what's our diameter? 50. So we'll just calculate that. 3.14 times 50 will give you 157. 157 centimeters. So for a car, for this car, or for the tire of this car to complete one revolution, the car needs to travel 157 centimeters. Okay, you can convert that to meters if centimeters looks small, if the unit centimeter is quite small for a car to travel. All right, so I hope you got that. A revolution is 360 degrees, moving when the tire moves from one point and it goes round and gets back to that point. That's one revolution, and that's another way of describing the circumference of a circle. That's why we use the formula for circumference, to find how far the car needs to travel for the tire to complete one revolution. And remember our formula, circumference of a circle is 2 pi r, which is equal to pi d, and that's what we did right here. All right, so for this second question, 2b and number 3, I would like you to try it out yourself and see if you can answer it correctly. We're going to start the next video by answering those two questions. How many revolutions does the tire complete if the car travels 2 kilometers? Remember, one revolution is moving 360 degrees, which is what we calculated here. The car needs to travel 157 centimeters for the tire to complete one revolution. So this is for one revolution. Now, the second question, it's saying how many revolutions does the tire complete if the car travels 2 kilometers? And that's quite easy to calculate. All you need to do is to convert 2 kilometers to centimeters, so you have the same unit you're working with, and see how many 157 centimeters can you take away, or can you remove from your conversion of 2 kilometers to centimeters. I don't want to give you all the answers, just giving you hints or steps on how to get the answer. So it's either you turn 2 kilometers to centimeters or 157 centimeters to kilometers, so that the two distances have the same units, and then you find out how many of the one revolution distance can you remove from 2 kilometers to figure out how many revolutions the tire will complete if the car travels 2 kilometers. Okay, I hope that explanation was detailed enough to help you work that out. And then for number 3, determine the angle of a sector with arc length 32 centimeter and radius 7 centimeter. So all you need to do is to make the angle and the formula for arc length, make the angle the subject of the formula, just like we did for numbers 1. You do the same thing here. Okay, so thank you for watching. See you in the next video with your correct answers. That's what we'll be starting with. Bye for now.